So this is the 2016 Junior Cert Higher Level Paper 2 and we're looking at question number 4. The triangle ABC is shown on the coordinate grid below. So here we have our triangle ABC. Now, part A says write down the coordinates of the points A, B and C. Okay, so for finding the coordinates we're always starting at the origin, the point 0, 0. That's the origin. So from here, how do we get to A? Well, we always move left or right first, or across. So we go left minus 1, and then up to the 3 on the y-axis. So it's minus 1, 3. So from the origin to get to B, we go right to 5 and up to 3. And to get to the point C, from the origin we go left to minus 1, and then up to 8. So minus 1, 8. So that's our coordinates of A, B and C done. Part B says find the equation of each of the lines AB, AC and BC. So the equation of a line is just the name of the line, or the rule that the XY coordinates on the line follow, or the rule that they obey. Okay, so let's go back and have a look at the lines. Well, the line AB is this line here, and the line AB is an infinite line. It goes all across this way. Now, it's a horizontal line, so if you just look at any point along AB, it's going to have a y coordinate of 3. So this point here is 5, 3. This point here is 1, 3. This point here is minus 1, 3. But it's always comma 3, and that 3 is in the y position. So we call this horizontal line y equals 3, because the y part of all the coordinates is 3. And also it crosses the y-axis at 3. So y is equal to 3 is the name of the line AB. All horizontal lines are named y is equal to some number. Okay, so if we now look at the line AC, well, the line AC is a vertical line, and any point on this line will have a x coordinate of minus 1. So for example, A is minus 1, 3. C is minus 1, 8. And this point here would be minus 1, 6. So they all have an x coordinate of minus 1. And you can see that that line, if you extend it down here, would cross the x-axis at minus 1. So the name of that line then is x is equal to minus 1. So all vertical lines will have the name x is equal to whatever number they cross the x-axis at. Okay, so BC. We go back and have a look at BC. Well, BC is this line here, extended out this way infinitely and this way. So we need to know the equation of the line BC. Well, you can see over here we've got some formulas from the tables book. Now, these two formulas here are the formulas for the equation of a line, and the one I'm going to use is the top one here. Y minus y1 is equal to m bracket x minus x1. Okay, so to use this formula we need to know m, and m is the slope. So we have another formula then here for finding the slope m. So we're going to use this first to find the slope of the line BC. So we're going to write down the coordinates of B and the coordinates of C first of all. So if we remember, B was 5, 3, and the point C was minus 1, 8. Okay, so if we're going to find the slope of the line joining these 2 points, we've got to label these points. So I'm going to call this point x1, y1, and this point x2, y2. You could have called this point here x2, y2, and this x1, y1, that doesn't matter. So what I'm going to do then is I'm going to just plug these values. The x1 value of 5, I would be plugging that in here. And the x2 value of minus 1, I would plug in there. y1 will be going here, and y2 would be going there. So my m value, my slope m, is equal to y2, which is 8, minus y1, which is 3. And that's all over x2, which is minus 1, minus x1, which is 5. And when I work this out in my calculator, I get a value of minus 5/6, minus 5 over 6. So that's the slope of the line BC. So now what I'm going to do is put this m value into this top equation here. So I've got y minus y1 is equal to m bracket x minus x1. Now I've chosen this formula here because I know what m is, and x1, y1 will just be any point on the line BC, so I can choose either C or B to plug in there. So this y and this x are going to remain as part of the name or the equation of the line. So here I'm going to have y minus y1, I'll just go with the point B, so y1 was 3, is equal to m, which is minus 5/6, bracket x minus x1, which was 5. So now I've plugged all these values here into my top equation, and so in other words I wasn't using this equation in this case, just the top one. And now I'm just going to tidy this up a little bit. So I'm going to multiply everything by 6 to get rid of this fraction, so I'm going to get 6y minus 18, multiply this by 6 and this by 6 is equal to minus 5 by the x minus 5. So if the bracket's outside, if the number's outside the bracket there, a fraction, and you times it by 6, you don't have to times the inside here by 6. So now that leaves me with 6y minus 18 is equal to, I'll just expand this bracket out, that's minus 5x, and minus 5 by minus 5 is plus 25, and finally then I'm just going to bring everything over to the left side. So I'm going to bring this over here, it's going to become 5x, and I'm going to bring the positive 25 over here, and that's going to be minus 25. So that's going to leave me on the left hand side with 5x plus 6y, and then minus 18 minus 25, that is going to be minus 43, and I'm left with 0 on the right hand side. So there's the equation of the line BC. That's the end of part B. So part C says use trigonometry to find the measure of the angle ABC. Give your answer in degrees, correct to 2 decimal places. Okay, so the measure of the angle ABC. If we go back and have a look, the angle ABC is this angle here. So we need to know the measure of that angle. Well, let's just mark it. That's the angle ABC. Well, there's a few ways you could do this, but seeing as it's a right angle triangle we have here, and it did give me the hint of saying use trigonometry, but if it's a right angle triangle we can apply sin, cos, tan, the trigonometric ratios. So if this is the angle, we know that this side here is a distance of, it goes from 3 up to 8, so that's a distance of 5. And then this length here, the length AB, starts at minus 1 and it goes to 5, so that's a distance of 6 altogether. So the angle ABC, we've got the opposite side is 5 and we've got the adjacent side which is 6. So we know then that the tan of the angle ABC is the opposite, which is 5, over the adjacent, which is 6. And that means then if the tan of an angle is this fraction, we can then find the angle ABC, will be equal to the inverse tan, so you press shift tan on your calculator, of 5/6. And the inverse tan of 5/6 on your calculator that gives me 39.8055, and on it goes. And make sure your calculator is set to degrees. There should be a little D at the top of the screen on your calculator. But they did say to round this correct to 2 decimal places. So I'm going to look at the third digit after the decimal. This 5, does this 5 affect the 0 in front? Well, yes it does. It's going to knock that 0 up to a 1. So my answer would be 39.81 degrees. And that's the 2 decimal places. Okay, so part D1 says find the length of BC. These straight line brackets here mean the length of BC. And give your answer in surd form. Okay, well, if we're looking to find the length of BC, there's a few ways you could do this. You could use the distance formula, which is down here, and just plug the values of B and C into this equation. But I'm actually going to do it using Pythagoras, which is really the same thing as this. So I'm just going to go back and have a quick look at the diagram. So if I'm looking for the length of BC, it's a right angle triangle, and I know these two sides are 5 and 6. So I'm just looking for this, the length of the hypotenuse. So just to draw a quick sketch, if you have a right angle triangle, this side's 5, that side's 6, and it's a right angle triangle, as I said, and you're looking for this side here, which we can just call the length of BC. Well, you can use Pythagoras. Pythagoras says that the square and the hypotenuse, so BC squared, will be equal to 5 squared plus 6 squared. So that leaves me with BC squared is equal to 25 plus 36, which is 61. Well, if BC squared is 61, well then BC, what we're looking for, will be the square root of 61. So, and they said to give our answer in surd form, well, then that's the answer. Root 61, that's already in surd form. And you can try and simplify that in your calculator. Root 61, put it in, and it doesn't simplify, so that's just the final answer, root 61 in surd form. That's the length of BC. Okay, moving on then. Part 2, D part 2, says hence or otherwise find the area of the circle that goes through the points A, B and C, and give your answer in terms of pi. Okay, so the area of a circle, well, there's a formula in your tables book for that. You can see it here. The area of a circle formula is pi r squared. So the area of a circle is pi r squared. So to find the area of the circle, all we need to find is the radius. So if we go back and have a look, if a circle goes through C, A and B, and we notice here that the this is a right angle, so that would mean that the circle would be something like this. I'm just going to sketch this. Something like that, roughly drawn. You can draw it with a compass as well, but if you have a triangle, and it's a right angle triangle, and all 3 points touch a circle, well then this line here must be a diameter for that to happen. If it's a 90-degree angle here, then this line CB will be a diameter. So if that's the diameter, so we know the diameter is the length of the line BC or CB, which we just found was root 61. That's the diameter. Well, the radius would be half of that. So our area will be pi multiplied by the radius, or which is half of root 61. So that's root 61 over 2 squared. So when you put all of this here into our calculator, we find that the area of the circle is 61 over 4 pi. And it says to give your answer in terms of pi, so we don't need to round this using the SD button on the calculator. That's just our final answer. And just be careful here, because it's area, you want to say that it's units squared. You don't know if it's centimeters or meters or whatever, because it's on the coordinate axis. So we just say unit squared. Okay, and finally, part D, find the equation of the line through the point A that is perpendicular to the line BC. Okay, so through A, perpendicular to BC. So basically we will be looking for a line that goes from A perpendicular to BC. Perpendicular means at right angles, so basically the line will look something like that. There. Perpendicular. Okay, so we want to know the equation of this line. Okay, well, what we do know is that if this line is perpendicular to BC, we know that their slopes should multiply to give -1. Or indeed, that one slope is the negative reciprocal of the other. So I'll show you what that means now. We know that the slope of the line BC, so if you remember, you can use slope formula here, but I'm just going to do it from the diagram. The slope is the rise over the run. So if we're looking at the line from B to C, from B to C the rise is 5, and the run is from B to A, which is 6. I've already got them marked in from earlier, so 5 over 6. However, this line here is sloping from down on the right up to the left, so that's a negative slope. You should know that. Negative slopes go up to the left and positive slopes go up to the right. So that's got a slope actually of -5/6. That's the slope of the line BC. Now, for the line going from A perpendicular to that line, well, the slope would be the negative reciprocal of this number. So the slope we're looking for, we can call it M2, will be the negative reciprocal of this is when you flip this upside down and change its sign. So the reciprocal is when you flip the fraction upside down. So 6/5. And if this is -5/6, it now becomes a positive. You change the sign. Or you multiply it by a negative sign, which does change its sign. So the slope we are looking for is 6/5. And then we're just going to use 6/5 and the point A, which is -1, 3, in our formula for the equation of a line, the same one we used earlier. So if you remember, the formula was y minus y1 is equal to m bracket x minus x1. So our point A, which was -1, 3, as far as I remember, -1, 3, yes. That's the point A, so that's going to be our x1, y1. And then our slope m was what we just worked out there, which was 6/5. So we're going to plug these values now into the formula for the equation of a line. So we get, y minus y1, which is 3, is equal to m, which is 6/5, bracket x minus x1. X1 is a -1, so just watch out there, it's minus -1. So now when we tidy this up, we're going to multiply across by 5, so we get 5y minus 15 is equal to, times this by 5, 6/5 by 5, that just leaves the 6. And then in here you've got your, this does not get multiplied by 5. So x minus -1, the minus and a minus sign beside each other becomes positive. So we have there. So now we're just going to multiply this out. So that will leave us with 5y minus 15 is equal to 6x, 6 by x, and then 6 by 1 is 6. And finally then we're just going to bring all this stuff here over. Bring that over here, it becomes a negative 6x. And bring a positive 6 over here, and it becomes a negative 6. So that will mean on the left side we have 5y minus 6x, and then we have minus 15 minus 6, which is minus 21. And we've got 0 left on the right side. So that's our answer for the equation of a line. There's other rearranged versions of this, but that's the one that I ended up with. And that's the end of the question.